next number we'll look at is the UPC code. Most people are familiar with the UPC code. This is the number by many barcodes on many products. The UPC code is a 12-digit code. The last digit is the check digit. The last digit is chosen so that 3A1 plus A2 plus 3A3 plus A4 and so on plus 3A11 plus A12 is divisible by 10. So 3 times the first digit plus the second digit plus 3 times the third digit plus the fourth digit plus 3 times the fifth plus the sixth plus 3 times the seventh plus the eighth plus 3 times the ninth plus the 10th plus 3 times the 11th plus the 12th. This is chosen, the last digit is chosen, so that that sum is divisible by 10. So example. Well, for example, notice the 3's go on the odd indexed numbers, and the others, the even indexed numbers, have coefficients of 1. So find the check digit here for this UPC. 0, 3, 8, 0, 0, 0, 0, 0, 1, 2, 7. Well, the check digit is 7, which I was just about to write, but we're going to find the check digit. Let's call it X. That's a lot of zeros, so this one will be a little easier. Maybe I'll come. This is an example from the textbook. I'll find a product in this room and see if that has one with fewer zeros. But let's find the check digit on this one first. Well, we need this entire sum to be divisible by 10, so let's write that entire sum. 3 of these, that's 0. Plus 1 of those, 3. Plus 3 of those, 3/8 is 24. With it written out like this, I'm going to make my life a little easier by underlining the ones that get a coefficient of 3. So with that underlining, those all have coefficients of 3, and the rest have coefficients of 1. So we have 3 plus 24, 0, 0, 0, 0, 0, plus 3, plus 2, because we need only one of those 2's, plus 21, because we need 3 of those 7's. And this is chosen so that that sum plus x is divisible by 10. The divisible by 10 is the same as ends in a 0. So we want this to be divisible by 10, so let's add them together. 27 plus 3 is 30, plus 2 is 32, and 21 is 53. So this check digit must have 53 plus x divisible by 10. 53 plus x end in a 0, so x equals 7. Because 7 is the next number, that'll make 53 end in a 0. Let's look at another. Let's take this product I have over here. Yeah, this one has a lot of non-zero numbers. This one will be a much bigger pain to compute, but with the much bigger pain to compute, it will be a more illustrative example. So let's write this digit down. 0, 2, 5, 1, 9, 2, 9, 2, 7, 6, 2, and the check digit, which is not written as an X here. This right here, we have season 2 of Leave It to Beaver, a fantastic television show from the 50s and 60s. I highly recommend you all watch, especially season 2. That's a particularly good season. Season 3 is quite good as well. Season 1 is quite good as well. 4, 5, and 6 are not as good. But where were we? Let's find the check digit here. So again, I'm going to underline the ones that get a coefficient of 3. Wow, that's going to be a large number with all those 9's. So 3 of those is 0, plus 1 of those is 2, plus 15, plus 1, plus 27, plus 2, plus 27, plus 2, plus 21, plus 6, plus 6, plus x. So we add all those together. Notice the x will always have a coefficient of 1 in this case, because it's the last digit. So we have one of those, three of those, 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 1 and 3. So we need this to be divisible by 10. Well, let's add these together. 17 plus 1 is 18, plus that is 45, plus that is 47, plus that is 74, plus that is 76, plus that is 86, 96, 97, 109. So we need 109 plus x to be divisible by 10. We need 109 plus x to end in a 0. And we get x equals 1. And then we walk back over to our season 2 of Leave It to Beaver and check. Yes, the check digit is 1. So it would be a good exercise to look at a product in your room and see that the check digit is correct. Now, the 12-digit UPC, where are my notes? There's an extension of the 12-digit UPC code, a 13-digit European code. It has 13 digits, and the last one is chosen so that the first one plus 3 of the second, plus the third, plus 3 of the fourth, and so on, is divisible by 10. And all UPC codes can easily be translated into one of these 13-digit codes. Remember that the UPC code is a 12-digit number, so that 3 of the first, plus the second, plus 3 of the third, and so on, is divisible by 10. Well, if we want to take a UPC code and translate it into one of these 13-digit codes, all you have to do is put a 0 in front of it. What happens if you put a 0 in front of a UPC code? Well, you have a 13-digit number, because you have the 12 from the UPC and then the 0 in front. That makes 13. But this equation down here is also satisfied, because the first digit is just a 0. And the rest is the UPC code formula. So let's do a slightly different example. This UPC codes and 13-digit European codes have a nice property that the previous ones don't necessarily have. And what is that property? Well, these codes, maybe they show up on a box or something. And say the box gets damaged somehow. And say, this is what you see on the box. 13 digits, 1, 2, 3, yeah, 13. Say this is what you see on the box. You see 1, you can't see the next number, and then you see the last 11. Well, we can use this formula to figure out what that x is. And we couldn't necessarily do that with previous codes. So let's use this formula to figure out what that x must be. Now, for the 13-digit code, it's the numbers in the even positions that get multiplied by 3. So I'm going to just underline all of them. 3, 3, 3, those. So those get multiplied by 3. All you have to do is add these numbers together now. So we have 1 plus 3x plus 4 plus 0, 0, 0 plus 2 plus 3 of those 2's. 3 2's make a 6 plus another 3 2's plus 3 3's plus a 4. Notice here we're not finding the check digit. We're given the check digit. Right here we're assuming that one of the numbers was somehow damaged, and we're trying to figure that out. So we know that this must end in a 0, must be a multiple of 10. So let's add these numbers together. 1 plus 4 is 5, plus 2 is 7, plus 12 is 19, plus 13 is 32. So 3x plus 32 must end in 0. 3x plus 32 must end in 0. Well, it's not immediate that there's only one solution to that, but let's figure out how many 3x plus 32's can end in a 0. A couple ways we could do it. I'm going to do it like this. What happens if we get the next number? 3x plus 32 equals 40. That's the next number that ends in 0. Then you get 3x equals 8. x equals 8/3. That won't work because we need it to be a whole number. What's the next number? 3x plus 32 equals 50. Well, what would you get here? 3x equals 18. So you get x equals 6. Well, that's good. We have a number. Now, is there any other number this could be? Well, let's check it like this. What's the next number that can end in 0? 60. 3x equals 28. X equals 28/3. 28/3, not a whole number. Now, you could keep going 70, 80, 90, and so on. If you went to 80, what would happen? Well, let's do that. 3x plus 32 equals 70. 3x, 32 plus 38 equals 70. X equals 38/3. 38/3, not a whole number. What's the next number? 3x plus 32 equals 80. Subtract 32. 3x equals 48. Well, that's okay in terms of giving us a whole number because we got x equals 16. But these are only single-digit digits. And 16 is a double-digit digit. So that won't work. So this shows us x equals 6 is the only choice that we could have for that corrupted number. Now, another way you could have reached that conclusion, that was the only number, is you could have said this. You could have made this observation. Well, these numbers are going to add up to 3x plus 32. What's the largest x can be? So we'll say the largest this can be is when. Well, x can be only numbers 0 through 9. So x equals 9 will make this the largest. What happens when x equals 9? 3 times 9 plus 32, 27 plus 32, 59. Yeah, okay. I was just checking something. So this would tell us the largest 3x plus 32 could be is 59, which would tell us the only equations we would have to consider are up to 50. So since this observation would tell us you don't have to check 60 or 70 or anything larger than that. So there are two ways you could have concluded this is the only number. You could have gone up to 80 and gotten that 16 thing, or you could have made this observation. And these, the previous codes didn't detect all types of errors. There were a few different holes in the errors that they could detect. Now these UPC code and the European code detect a lot of the common errors. According to the textbook, where is it? It detects all single position errors and about 90% of all other errors that you could see. So that is pretty good.